right, Algebra 1, semester review, spring 2025. Here we go. Multiplying two binomials. There's two terms here, two terms here. So we do the first term times the first term, and the first term times the second term. 5x times 4x. 5 times 4 is 20. It's called double distribution. Right? 20x times x is x squared. 5x times negative 2, don't forget that negative, that's negative 10x. And then if you distribute the first term, then you have to distribute the second term. 2 times 4x, 2 times negative 2. So 2 times 4x is positive 8x. 2 times negative 2 is negative 4. Now this doesn't match any answer choice because we need one more step. My x terms, my like terms, I must combine. Negative 10 plus 8 is negative 2. Okay, if you're not sure about that, you got to use Desmos, use your calculator. Okay, 20x squared minus 2x minus 4. Okay, and the answer is going to be B. Okay, now on the calculator, what you could do is use the letter A instead of X, not X, and then set A equal to 2 and solve it from there. So for example, if I type this in using A, 5a plus 2, 4a minus 2, okay, and then I set a equal to 2, it gives me 72. So then all I got to do is start typing in my answer choices. So when I type in that answer choice of B, I get the same value, okay? So again, you can change X to A, set A equal to a value, plug in your answer choices to see which one is the equivalent, okay? This is a test strategy for equivalence, all right? Well, number 2 here, simplify, okay? Now, you can do, and then check, right? Well, you can do that here, over here. You can also do it down here, okay? I could type in this whole thing, and then I could also, with A, set A equal to 2, type in the answer choices, which one gives me the same value, okay? Well, I'm going to tell you, if you see a minus in front, that really means minus 1, okay? So a negative by itself means a negative 1, and then you have to distribute it. And when you distribute a negative 1, all it does is change the signs. So positive 2x cubed is now negative 2x cubed. Negative 1 times positive is negative x squared. Negative 1 times negative 2 is positive 2. I'm going to bring the first terms down, the first parentheses, that polynomial. And now all I got to do is combine like terms. All right, so you got what? 4x cubed minus 2x cubed, which is 2x cubed. Negative 3x cubed minus 1x cubed. Sorry, negative 3x squared minus 1x squared is negative 4x squared. Positive 6x is the only x term. And then we got negative 4 plus 2 is negative 2. All right, so my best answer, the one that matches, is letter D. But again, if I had typed in the original with A, set A equal to 2, and then put in my answer choices, I would have gotten D as well. Okay. Well, what is the solution to this? Now I'll show you how to solve it by hand, but remember, uh, you can use N and use the squiggle and in Desmos to get the answer, right? So just real quick. So 9n minus 3, 6n plus 4 equals 42 plus 8, 3n minus 5. All right. So negative, and then as you type n, click this button, negative 14 over 33. Okay. Well, let's see if that's what we get when we do this. You have to distribute and distribute. Negative 3 times positive 6 is negative 18r. Negative 3 times positive 4 is negative 12. Bring down the 9r. 8 times 3r is 24r. 8 times negative 5 is negative 40. Okay. Cool. You can combine like terms here. 9 minus 18 is negative 9r. Bring down minus 12. Bring down 24r. And then you can combine like terms. 42 minus 40 is positive 2. Get rid of the smaller r. To get rid of a minus 9, you add 9r. Negative 12 equals 33. R plus 2, subtract 2, you get negative 14 equals 33r. And your last step is to divide by 33. You get negative 14 over 33, which is what we got when we did it the Desmos way. So no matter how you do it, that's how you can do it. Okay. All right. So given the table, write the equation for the line of best fit. Okay. Now, if it's exponential, okay, you go to Desmos, you do plus sign table, you put it in, and then you're going to do y1 squiggle ab to the power of x1. You got to do it that way. Okay. So let's put this in here. And again, you have to type it in correctly. Y1 squiggle A B, and to the power of is this button right here, the A little b, to the power of x1. Okay, and you'll see an A value and a B value. A value is 16, B is 4. So it's y equals 16 times 4 to the power of x. Cool. All right. All right, we want to factor. Now, once again, you can do Desmos, you can use A and then set A equal 2 and check. That's one way you can do it. Okay, the other way we can do it is what are the factors of the C value that add up to make the B value? So negative 24, 1 times negative 24, negative 1 times 24, 2 times negative 12, negative 2 times 12, 3 times negative 6, 3 times negative 8, I should say, negative 3 times 8, 4 times negative 6, negative 4 times 6, okay? Now out of all those combinations, which one adds up to positive 2? Negative 4 plus 6 equals 2, which is what we wanted for our B value. So this is our C value, this is our B value. So it's going to be x minus 4 and x positive 6, so plus 6. And that's going to be C. Even if you swap C's it, it'll be the same thing. Commutative property. Cool. What are the solutions? You can graph this thing and find the x-intercepts. Okay, that's one way to do it. X squared minus 4x minus 5. Boom, boom. Negative 1, 0, 5, 0. That's it. Okay. Now, if you wanted to factor, you could factor it too. Negative 5 is either going to be 1 times negative 5 or negative 1 times 5. And the one that adds up to make negative 4 would be this one. X plus 1, x minus 5. And then you set each of these equal to 0. Because that's how you solve, is when you have it equal to something, it's equal to 0. And after I solve each of these, I get these two solutions. Cool. Vertex. Vertex is the change of direction. It's either a minimum or a maximum. And in this case, it's a minimum. At the bottom of this graph, right here, is negative 1, negative 2, right? All right. What's the equation of the axis of symmetry? Axis of symmetry goes through that vertex vertically, okay? And an axis of symmetry is always going to be going through the x-axis. So it's always x equals, not y equals. What x value does it go through right there? It goes through negative 2, which is not on here. So it's supposed to be x equals negative 2. No, my bad. That's a lie. Notice the lines are not one unit. If this is negative 2, then this is negative 1. So x equals negative 1. That is correct. Cool. Describe this graph. How does it compare? Okay, so we're circling things, okay? You literally just graph both in Desmos. And compare. Let's do that. So we have f of x equals x squared. So I'm going to start with this one. Okay, and it says g of x equals 3 f of x minus 1. Okay. So my original f of x is my parent function here. My new one looks like it got shifted down 1. And then that 3, instead of going over 1, up 1, let's see here. Yeah, instead of going over 1, up 1, it's over 1, up 1, 2, 3. So, yeah, it's vertically stretched by a factor of 3, and it's shifted down 1 unit. Okay, so you can just see this stuff when you graph it and compare. So graph and compare. Number 10, simplify. Let's do it. Now in Desmos, you could just type in and compare the decimals. You can compare the decimals, that's fine, but check this out. Square root of 125, does 2 go into 125? No. Does 3? No. What about 4? 4 is not prime, so 5 times 25, and then 25 is 5 times 5, 1 pair, 1 loner. Pair goes out, loner stays in. That's how it is. Don't forget the factor tree. Okay, which quadratic is represented here? Well, you can graph and compare if you want. Okay. 1, 2, 3, 4, -4, 1, 2, 3, -4, -4. So if your vertex is -4, -4, the vertex form would be x insiders lie, and then outsiders don't lie, which would be C. Okay, but let me show you. If you graph C, okay, -4, -4, x-intercepts of -6 and -2. I mean, it matches perfectly. So again, you can graph and compare. You don't even have to really know the vertex form. Okay. Identify the roots. What's a root? X-intercept. All right. So there it is. There it is. -4 and 0. Another way to write it is x equals -4, x equals 0. Another way to write it is -4, 0, and 0, 0. These are just 3 different options. You have set notation, solutions, and ordered pairs. That's what a root is, x-intercept. Domain and range, it's going forever to the left and forever to the right. All real numbers. Now the range, this does not cross this line, right? So there's an asymptote at y equals 0. It doesn't touch 0. So that means the y value is going to be greater than, it's going up, not equal to 0. Okay? Well, which graph represents it? Let's graph it. Okay, so the graph we're looking at here is 300, 0.15 to the power of, this is power of x. Okay, now just looking at the shape of it, A doesn't have the right shape, B does, C does, D does not. Okay, now if I zoom out a lot, find the x-intercept here, sorry, the y-intercept is at 0, 300. 0, 300 is here. 0, 3 is here. Which one has the right y-intercept? Well, remember. Oh, wait. Hold the phone. Is that 300 or 3.00? 3.00. Okay. Is right there. Okay. So again, I don't know if that was an accident or not, but if you have 3.00, that's going to be at 3.00, which is just 3, right? It's not 300. Cool. So it's not going to be B, it is going to be C. All right, last but not least, okay, you can use A for X, you can use B for Y, set A equal to a number, start with 2, set B equal to a number, a different number like 3, and then you can compare the answers. All right. But I will show you the math of it. 20 divided by 2 is 10. Top minus bottom, this is x to the 1. So 3 minus 1 is 2. And 3 minus 2 is 1. Okay. Answer C. Let's do the graph and compare stuff. 20x cubed, y cubed. So 20a cubed b cubed all over 2xy squared 2ab squared. Okay, if I do that and I said, hey, a equals something, and then b equals something else, I get 120, and then I type in this answer choice, 10a squared b, they match, 120. All right, that's it for the review. Make sure you study it and you're ready for your final.